Hello there, it's Jay here from Jay's Vintage Junk, and this is going to be part 2 of the Hacker Black Knight refurb. Now fortunately my fingers have healed well enough to fiddle about with stuff like this again. And I went to see my mate Andy over at Vintage Electronics Repair the other weekend, and he very kindly gave me a scrap per Hacker what is it now? It's a Hacker VHF Herald, just a parts radio, but fortunately it had the front end transistors were still in it. So I've got a set of transistors here that we can try in that amplifier. Now they're not actually the correct transistors for this amplifier. They're actually from the one before, the previous iteration of these little Hacker amplifiers. But I've had a look, and I'm pretty certain they should work. We may have to, like I said, we may have to tweak the voltage and the current thresholds using the potentiometers, but I think they should actually do the job, so we'll try installing them shortly. Before we get onto that, what I think we'll do is see what we can do about the damaged speaker cone, because there's no point getting the amplifier fully up and running if I can't sort the speaker out, because I haven't actually got one. I did have a look, see if I had something I could stick in there, but I don't actually have one of these oval speakers of this size that actually fit the Black Knight. But it's not bad damage to it. It's just one small tear there, so it's quite easy. We should easily be able to repair it, and I'll show you the way that I actually do this. What we've got here, basically what this is, it's a 50-50 mix of craft glue, basically children's PVA craft glue and water. That's all I use. We'll open that up. I'll have to give it a little bit of a stir, because that's been in the that jar for quite some time. Like I said, I use this whenever I need to repair a speaker cone, or if it's a very old speaker cone and it's gone really fragile, you can actually renovate and refurbish a bad cone like that with this. But we'll give it a quick stir just to mix it all back up again. Like I said, it's like a thin glue now. Like I said, it's not thick like the craft glue is when you used to use it in infant school and used to spread it everywhere with them little plastic spreaders. Right, let me see if we can find a small paintbrush. Ah, there it is. And basically all we want to do to start off with, we just take my paintbrush. We'll get some of the mixture just on my paintbrush. It's going a little bit gloopy in the bottom here, but that won't matter. And what we want to do is just paint basically over where the damage is, very gently. We'll just paint over the damaged area of the speaker cone. We really want to try and avoid getting it round the edge there, because we don't want to distort the sound. Alright, the next thing we need is this is just kitchen paper, just common or garden kitchen paper. If you can get one of the ones, like the ones that say, you know, like extra strong or something, that's the best. I either use this or a product called Blue Roll, which is like an industrial blue version of this that doesn't have fancy patterns in it. That's even better, but I've just run out of it at the moment. We want to cut just a small patch like that. That's going to be large enough to go over the actual spot where we need to do the repair. Okay, now we'll have let that just tack off while we've just been talking. So all we need to do, we'll basically just place that over where the damage is. In fact, I'm just going to quickly pull that back off and just trim them two corners. Just pull it back off. I'm just going to snip that corner off there. Oops, I have just dropped it. Hope I don't run over it with my with the wheels on my chair. Just, I mean, it doesn't have to be super neat or super accurate, this, but that should be better. So we don't want it really to go too. There we go, that's ideal. Just brush that down. And then basically what we want to do, a little bit more of the PVA solution just on your brush. So you don't want to absolutely saturate the cone, but we just want to then just go over this with the PVA solution, get that paper really well soaked with it. There we go. And basically that's it. We'll put that away. Now if you're bothered about your brushes, you do want to wash your brush at this point, because as soon as that goes hard your brush is ruined. But this is a water soluble glue, so if you wash your brush out now, you can reuse your brush again and again. So in fact that's, I'm just going to go out and wash my brush out, and I might go and have a quick brew. And then when we come back, that should be nice and dry, and we can get on with seeing what we can do with the amplifier. So back very shortly. Okay, well the speaker still isn't quite dry yet, but we might as well get on with reinstalling the new transistors in the amplifier board. We'll start with TR3 there, which it was a T2 originally, but I'm not sure. That T2 probably does still work, but in the circuit that I've pinched the output pair from, T2 isn't, well, TR3 as it should be, isn't a type T2, it's an AC128. They're both PNP transistors. I'm going to actually try an AC128 in there, like I say, because that's what came from the other circuit. We might as well get that in as the first one. So, let's collector, base, oops, and emitter in there. We'll quickly spin them around and we'll get them soldered into place. Let me just grab my glasses. My eyes are definitely not getting any younger. Oops. Put that out of harm's way for a second. Right, let's get in here and see if we can solder these in place. Okay, so that's the first transistor replaced. That's a nice solid join there. Right, now let's put in the other PNP transistor, which is TR6, which is that one there. So let's look, and again that's going to be replaced with an AC128. There we go, that's an AC128. I'm not 100% sure this is going to work, but I'm pretty certain it should be okay. So if it doesn't work, then we can always go the silicon route. Push that in there. These eyelets do make it quite nice to actually solder this into position, and it does certainly make for a high quality set. Oops, that one. And you don't want to heat the legs up any longer than you really need to with these old transistors. Especially these old germanium ones, they do seem quite susceptible to heat damage. So if you can do a really nice quick solder job, you're all the better. Right, so we've only got TR5 to go now. So that goes in the other way around, because the collector's on the other side. There we go, that's through. We can just solder that in place. Oops. Make sure we get them properly through the holes. Hopefully you can see what I'm doing here. There we go. Oops. There we go. Okay, so we've got the driver and the two output transistors replaced there. Now what we will have to do before we even switch this on is just pop the heat sinks on, because the transistors, you know, well, saying that, without driving any load into it, they shouldn't go crazy, but even so, you better be safe than sorry with these transistors. So I will stick the heat sinks on before we go any further. Okay, there we go. Let's have a look at the speaker. The speaker's it's nearly dry, not quite dry yet, but it's nearly dry. It'll be good enough for us to do a little bit of testing with anyway. So the first thing we should do is see if we can set that voltage using RP1 there. So what we need, let's find a suitable meter. In fact, I'll get zoomed out a little bit so you can see more what we're doing. Oops, wrong way. Right, there we go. Right, you can kind of see what we're doing here now. Right, we could do with some crop test leads actually, but we'll have to make do with what we've got. I might as well use this 12 volt battery, seeing I know that's fully charged to power this thing. We're going to have to make some temporary connections to the speaker. Right, so where's that temporary lead? And we'll lash some test leads on. Like that. Oops, that one's going to need to be a little bit longer. There we go. Right, so that's our test speaker lashed up. Not the most ideal way of lashing a speaker up, but it does work. Right, let's see which way that needs to go. So that goes on, oops, between A and B there. Connect that one to B, connect that one to A, like that. So that's our audio output connected up. So we can give it a load on its output. Right, now we need to connect the where are my, there they are, where are the crop leads. In fact, what we could do, we could pinch the leads out of my transistor analyzer here, or my component analyzer, because they have crop leads on one end. Oops. Which will make life a little bit easier for connecting this up. Right. So we'll set that's set to 20 volts. We'll use yellow as common. Oh, Will that go in there? That works. For some reason that doesn't want to plug in there. That's a bugger. You don't want to force it and damage the socket on the meter. I'll use this lead. There we go. Now we need to connect that to our ground. Well, that's all set up. Right, well, where are the crocodile leads that I've got? There they are. Right. Now let's see where does power want to go in. F is power. Is it? Yeah, F is power. E is ground. There we go. F there's power. I can go to the battery. In fact, we're probably safer, just thinking about it, not using the battery and using my variable power supply. Because I know my variable power supply can only output 500 milliamps, as where that battery potentially has the output of about over 7 amps if we was to short it out. So if we've got something wrong, using the variable power supply here will actually protect what we're doing. I'll leave that set to the milliamps range so we can monitor. There we go. This is a more sensible way of doing it. We'll clip on there. So that's basically the circuit connected up. That's our input there next to the ground, so we can touch that and see if we get a buzz out of it. Right, so that's set up, the meter's connected. We just want to connect that, well, ideally to a ground point, so we'll connect it on there like that. And the plus from the meter, we want to connect to the positive on this capacitor, which is the same thing as basically going between those two resistors there. It's just easier to get a connection over there, but they're basically connected by a trace underneath. Okie dokie, so we're all set up there. Let's switch that meter on. And what I should really do is start at 0 volts, and we'll actually use the power supply to wind the circuit up, and then the idea of that is if we see any smoke emitting, we can quickly knock the power off and minimise damage. I don't think there's going to be anything wrong here, but like I said, we are using some transistors which were never originally intended for this particular hacker, but like I said, they should be quite up to the job. So let's power up the bench power supply. We can always tell something's wrong because I am up to that 12 volts. No, I still can't. See, I still can't vary the. I'll switch off. We've not got any current there at all. Something's not right. There's something very, very odd there because, like I said, we're connected up. We should ideally have about 5.5 volts there. We've got 11.2, and we should be able to vary that by varying RP1, and it does absolutely nothing. But if we look over here, this is set in the current mode. You can switch between volts, where it's about 11 volts there, and switch it down to current, and this goes up to 500 milliamps, and as you can see, we've got absolutely nothing showing there at all, so there's virtually no current draw. Transistors are all stone cold. Let's see. No, we're getting zero on there. Let's just see if that makes any difference at all, which no it doesn't. We'll set that about midpoint. That's for setting the current, the collector current on the output transistors, but so we should be able to set that voltage and it's doing absolutely nothing. And the transistors are staying cold, they're not even getting warm. So there's definitely something not quite right yet. Definitely we're getting something something out of the speaker, but we're not getting anything at all. No, those are staying absolutely stone cold. I wonder if we could just quickly try it in the radio. I don't think it'll do anything, but let's just quickly try it in the radio. But I think we've got another fault somewhere. I know all those transistors are absolutely stone cold. We'll just really quickly rig it up in the radio. Just pull my temporary lashings where we have that other amplifier lashed in there. Oops. So we won't run it for very long because we've not really got proper heat sinking on them transistors, but we can run it for a moment. We'll connect the speaker. And we could have a issue. Oops, we could have an issue with the speaker, but I doubt it. Well, that had something in it. Did you hear that pop then? So why didn't we get a pop when we tried it before? Let's try connecting this up to some power. Again, we'll where's the black wire? We'll run it from the bench supply so we can limit the current to, like I say, it can't go run away with itself. Right, that's on. That's set to about 12 volts. So the amp is working. Now I've got to be very careful what I do here because I got a copyright strike on the last video, so I couldn't do any monetization at all. Look at what it's got. Not really got an aerial on it, so I don't know how much we're going to pick up. Let's see if I can just connect something up as a temporary area. See, that's full volume. Absolutely full. Oh, we are getting a little bit of but that is with the volume control turned all the way up. Right, let's just feel Louis. Let's just disconnect the power. And what I want to do is just feel how warm those output transistors are. and they're still absolutely stone cold. So we've definitely got another fault on this amplifier. Like I said, I have tested the electrolytic capacitors in circuit just with my ESR tester, and they all tested absolutely fine. I wonder whether it might just be quicker just to lift one end of them and actually just test them out of circuit, just to make sure there isn't an issue like that. Other than that, like I said, these resistors, they can go noisy, but apart from that, usually they're reasonably reliable. I can't really see they being an issue. There's a possibility with one of these ceramic capacitors, but again, generally speaking, they're incredibly reliable. Really, apart from that, we've got basically TR1, TR2 and TR4 there. Now I think I mentioned in the previous video, if I was going to suspect any one of them transistors, I think it would possibly be TR4, which I could think could possibly be at fault. So what I think, like I said, what I think I'm going to do is I will lift one side of each one of these capacitors, and we can just quickly test them. We'll test them again for ESR, and we'll just test them for actual capacitance. And then I'm going to think I'll pull out TR4, and we'll test TR4 out of circuit, and we'll see where we get from there. I'll just to shorten the video slightly, I'll just pause while I just whip one end of each of them capacitors out, and then we'll come back and we'll do a bit of testing. So back in a sec. Okay, hang on, let me just turn the I'll just turn the desoldering station off. As you can see, I've lifted the positive leg on all those. Oh, I've missed that one there. I have desoldered it underneath, so we should just be able to just pull it through. There we go. I've desoldered the positive leg on all those electrolytic capacitors, so we can do a proper test on them. We'll use. Hang on, where's my other wire gone now? Oh, I plugged it in there, didn't I? Let's just unplug that. I'll switch that off as well. We'll use my little cheap Chinese component analyzer here. It's absolutely fine for doing things like this. It's one of, I mean, have you ever watched Shango's videos? He has one of these, but it's just this is just the bare circuit board. Is where I mounted it in a little case and added a continuity buzzer and what have you to it as well, just to make it a little nicer to use. But it's exactly the same thing. We'll start with this 1000 UF here, so we'll clip on, and we'll see what the analyzer tells us. Unfortunately, this is getting a little bit tired now, and the little matrix is starting to fail. Right, well it's showing 1200 UF, and it's 1000 UF cap. As they start to age, they can go up a little bit in value like that. But it's still reading as a capacitor, and like I said, providing it's okay for ESR, I wouldn't be too concerned about it. It's certainly not short or open circuit or anything like that. Right, let's try this next one, which is a 150 UF. So we'll connect on. Press the button. Okay, that's showing 168 UF. It's 150. Again, absolutely fine that. We will test them for ESR, but so far it's not looking bad. Let's try this next one. This next one is a it should be a 47 UF, and it's actually showing us 33. So that one we might suspect, actually. It might be a little bit iffy. This next one again is, what's the value on it? It's 100 UF. So let's try this one. because all these capacitors will be getting to the end of their life really. 114 again, that's not bad, that's fine. And this little one, which is a, what is it? Come on, what's your value? 22 UF. $26 UF again, there's no problem with that. So let's test them for ESR now. We'll get that tester out of the way. We will grab my, again it's only a cheap Chinese one, but it does work. We'll switch on. It'll ask us to short the probes together to calibrate. Okay, there we go. We'll start with 1000 UF. And this is 1000 UF at, you do need to know the voltage rating as well. I think this one is 10 volts. It's 1000 UF at 10 volts, so it's on this scale here. So we need to connect plus to plus, minus to minus. So 0.14 ohms. If we look along the chart here, for a good 1000 UF, 0.12. So it's there. You basically, there's nothing wrong with it. The next one, we say this is 150 ohms at 25 volts. So let's connect up. And if we look on here, it's a it doesn't have 150, but it has a 100 and 220. So we take somewhere between them two at 25 volts. We're looking about 0.50 of an ohm, and we're 0.08. So that, I mean, that's well under, no problem there. We'll move on to the next one. This one is, again, this is a 47 UF. This is one that I might suspect could be a bit iffy. Let's get in there. It's a 47 UF at 25 volts, and it says it can be up to 1.6 ohms, and we've got 0.16. So again, there's actually, it's a little low on capacitance, but I don't think it's going to cause, it's not going to cause a problem basically. Let's try this next one. Now this one again is, this is a oh, this is the 100 at 10 volts. We'll clip on. It's talking of 0.15, and if we look at 100 at 10 volts, the maximum is 0.70. So again, there's nothing wrong with that. We'll test this final one. What do we say this one was? It's 22 UF at 25 volts. So let's get on there. And it's a 22 UF at what did we say, 25 volts. So it can be up to 1 ohm. We're showing 0.24 of an ohm. So basically all those capacitors test both in their capacitors. That, yeah, I know that one's slightly low, but it's not low enough to really concern me. So basically I'm quite happy to reinstall all these capacitors, knowing that they at least check out for both, that they're reasonable in capacitance, but they test out for ESR as well. So like I say, I'm not concerned that they're going to be the culprit. I am more inclined now to think that it could possibly be TR4, which is at fault. Let's just get these we'll get these capacitors all nicely back in their holes like that. We'll get them soldered back into place. my iron a quick. There we go. Let's try that now. That's better. That's 1, 2. Should be fine, I think. 3. Now where's the other ones? There's 1, 4, and there's the final one. 5. There we go. So that's the capacitors reinstated. So I think the next thing I'm going to do is take out TR4 there, and we will test that out of circuit. Okay, we're back. Unfortunately, actually a couple of days have passed, and I did lose a tiny little bit of footage, completely and utterly my fault as well. I was transferring off, because I've only got one good SD card at the moment, and I thought I'll take all the video that I've taken up to now off it and put it on my computer. I thought I took it all off. I must have missed one file, and basically yeah, I deleted about 4 minutes of footage. It's nothing. Basically what I'll have to do is I'll just have to go through what I've done here, but like I said, we've not lost anything major. So what was in the previous video, I was saying I was suspecting TR4 may be at fault there. Anyway, I pulled TR4 out and stuck it on the cheap Chinese component analyzer, and indeed it was faulty. That's it here. Fortunately, what is it? It's a BC159. I had a rummage through my stocks and actually found nice new old stock one. So I did stick a nice new old stock BC159. So yeah, 159 in there, and well, I'm happy to say we have some progress. The amplifier does appear to be actually responding now. I've managed to set the voltage on it. Anyway, I managed to set that to 5.5 volts. I'll just show you. I'll show you that now. Actually, if we we'll get my tester here, hopefully you'll be able to see the screen on that. We'll switch that on, and if I put my bench supply on, I'll switch the radio on. And then if we check that test point there again, we can see there we've now got 5.1. In fact, that's slightly low. It's showing 5.1 volts. We want about 5.5 volts. So all we do is we go in that RP1 there, and we'll just tweak it up ever slightly. That was a bit high. That's close enough. Let's see if we can get it a bit closer. They are very finicky to get it absolutely perfect. That's close enough. But anyway, basically, before, as you said, when we tried adjusting that potentiometer there, it was just staying at about 12 volts all the way through the circuit. As soon as I changed TR4, we can now use the variable pot there, and it was I was easily be able to set that down to the correct 5.5 volts. What I've not done yet though, and what we're going to do now, is set the is it the incandescent current? Basically using the other potentiometer there. What we'll do is just power the radio off while we're fiddling with it. There's a little test point. I don't know if you can make that out there on the PCB. What we need to do is we need to break that test point and connect a milliammeter up in place of that test point. We can then set RP2 there, and we want about 3 milliamps flowing through that test point. We can reconnect that link after we've done that, and that should be the amplifier actually fully sorted, which will be a nice place to get to. So the new transistors seem to be working alright. It does, even without setting that, actually just running the radio, it does seem healthier. I won't run it for too long because we've no heat sinking on the transistors, and like I said, we do still need to do that one setting there, and then I'm actually quite happy with the amplifier. That should be a good amplifier for this thing. And then we've just got other major issues to sort out on this radio. Right, so first thing we need to do, let's get that wire link there lifted out, and we can I think the best way of doing this should be, in fact, if I lift, let me just be able to lift one end. Oops. There we go, that's one end lifted up. Now what we need to do, it's a little bit fiddly this, because really we need to leave it connected up to the radio while we do it. I've got that split off there. We'll get a couple of crock leads. I'll pinch that one and yeah, we'll have them two. Pinch them out of my little component analyzer. I'm currently using one of them as the aerial for the radio, while I was just playing it before. Right. Then we take the crop clip side. We can clip that onto that blob of solder under there, like that. That's one connection. And plug that into the meter, like that. We can get this up so you can see what we're looking at, and obviously we want a different range on here. We want to go down to the milliamp range, and we want UAmps at 200. Oh, about 20 milliamps there. That should be fine, the 20 milliamp range. And we want to connect that to there, like that, and that to the other side of the test point. So basically, like I said, we've got the test point lifted, we've got the meter connected in place of the test point, so we can actually see what the milliamps are up there, and we're looking at setting this for about 3 milliamps by varying Pt2 there. Now, so if we switch on the radio, you can see there we're up at 5.48 milliamps, so we need to see if we can get that down a little bit. We're going the wrong way, so let's go this way. There we go. Bring it in. 3.1, yeah, I think that's close enough. Yeah, that should be fine. So that amplifier now is actually correctly set up. So hopefully we should have no more, yeah, I mean, it's not run long enough for them to get hot, but we should have no more horrendous overheating issues with the output transistors. I'm actually wondering, possibly, whether reasonable scenario with this thing is that at some point did someone connect the battery backwards, which could potentially, I think, have blown that transistor. With that transistor blowed, obviously, it looks like we're getting the output transistors were being driven pretty damn hard, and basically one of them eventually failed. I mean, it's amazing that this amplifier was actually giving I wouldn't say reasonable output, but unless you cranked it up, it only just started really when you really give it a good cranking. Apart from that, it was actually basically running, even though one of the output transistors was pretty much dead. But no, like I said, there was no point just changing that. There we go. Push that back through. Ow, that burnt. Slightly singed my finger then, but never mind. So that's the link connected back up. Let's give it one quick last test before we put this thing all back together. We'll use that one again, 'cause it isn't. Oops. Nice long wire. Hope I'm not going to get a copyright call from this bit of classical, because I got a copyright strike on my last video on this radio for playing like literally about 15 seconds of something. It's getting a bit ridiculous, to be fair, because we are meant to have, you know, fair use. Let's have a see. Yeah, it can definitely go a little bit louder now. Right, what I'm going to do, I'm just going to reassemble the amplifier back actually into its enclosure. I won't bore with you watching me do that, and we'll come back to this as soon as I've got the amplifier actually mounted back in the chassis, and we'll look at the next major issue with this radio, which is the complete and total hash job someone's done of restringing it in the past. I've actually got the stringing diagram for it here, and it's been strung totally incorrectly, so we'll have to go through that. And I really hate stringing radios, but we'll do a quick restring of this thing. Sorry, just bear with me, folks. Okay, as we can see, I've actually managed to get the amplifier back in the actual radio. That was a little bit more of a faff than I originally anticipated. I was struggling trying to get that top fixing up there in, and then, like the idiot that I am, I realised if I just undo them 2 screws there, I can take this entire plate off, fit the amplifier to it, and then just screw the plate back on, which is basically what I did. So we have got the amplifier back in the radio chassis. So the next thing we need to tackle really is this dial card here. Now, which way up is it? I think according to the diagram it should be that way up. In fact, let me see if I can just drop you down a bit. Ooh, there you go, you're coming down. I'll go up a bit and zoom you in. Right, there we go. You can get a better idea what we're actually looking at here. So basically, the way that the dial's strung there, I know is incorrect. I've actually got the dial string data for this radio here. Apologise, it's a little bit on the mucky side. It fell on the floor and I run my chair wheels over it before I realised what had happened. But anyway, if you see here, it shows, for one thing, it shows a spring, and it shows 2 separate pieces of dial card, and the way the pulleys go around. If we look here, we haven't got a spring, and the way the actual dial cards goes round is actually not correct. The spring should be up here, there, and then it should go down, and that should actually go onto the drum there, round, off the drum onto there, and then over that pulley wheel there. So basically that has been strung incorrectly. Now, I could leave it as it is, but the problem is I don't think some of the stations are in the right place on this. I think someone's been twiddling about with the alignment on it, and I can't do anything about that if the dial pointer isn't accurate, or isn't at least working correctly. So I think the first thing I need to do is address that. And I will say now, I absolutely hate, loathe and detest restringing radios. It's one of the most horrible jobs you can do on these radios. I did one for a friend not long ago, a little communications shortwave receiver, and I was pulling my hair out quite a lot doing that. The other thing is, this isn't even dial card, it's string. This here is actual dial card. See, it's a lot thinner, it's actually quite stiff. You used to be able to buy this very easily. I think there's a few places on eBay still sell it. What I do, generally speaking, is if I'm ever scrapping a radio or a hi-fi system or anything that's got an analog tuner in it that has a dial card and pointer. If it's still in good condition, I always save them. Just wrap them up like that and put them in a little box, because, like I said, you can reuse them and it saves you having to buy. Like I said, it is getting harder to get. Like I said, I think there's a few places on eBay that might sell it, but it's rather expensive. If it's still in good condition, you might as well recycle. I mean, this is possibly off like 70s or 80s hi-fi system or something like that, something cheap and cheerful that would have still had a string dial pointer. I save lots of them off things like that. Anyway, let's get this piece of string out of here, and then we can actually look at restringing it. There we go. And there's far more turns around there, I think, than there's meant to be. Oh. Get that off there. I mean, it's fairly tough stuff. That it's probably done a reasonable job as dial card. I must have confessed before, now I've used things like kite line and all sorts of stuff to replace dial card with, but it's never seems quite as good as proper dial card. Right, I'll get the pointer out of the way for a second. I don't think that's right. I think that should be straight. I think that's been that's better. That's better. Because it doesn't show it cranked on the diagram there. Right. Let's see if we can unthread this. There we go. There's the end of it. And hopefully this is going to be long enough to do what we want. I'm not 100% sure what this has been salvaged off, but it is quite a nice long one. Right. And it is very, very tough stuff. Right, okay, so we've got some dial card there. And what it calls for is we need a piece which is 300mm long with a loop on the end, and then the spring on one end of it. And then we need another piece which is 668mm long. So I better get a tape measure and we'll see if we can measure out what we need here. Hopefully I've got a tape measure in here. There we go. We need a marker of some description, that'll do. Doesn't have to be anything, does that still work? Yeah, that'll do. Right. Now, so what we need is we need 300mm to start with. I'll put the tape measure down. We'll put the spring at the end there, and we'll mark 300mm on the dial card to there. And then we need to cut it a little bit longer than that. What we want to do is form a loop on that end there. So we'll cut it just a little bit longer than that, say about there. Now there's various ways you can form a loop. You can use little metal eyelets, but what I'm going to do, I'm just going to tie a loop. You just have to bear with me a second. I've just got to concentrate while I get this little eyelet through, this little loop through here. Can be a little bit fiddly. to start that again. Basically what we do is we fold it over, so we keep that little green bit there right at the end. It would have been easier if I possibly left myself a little bit more slack, but it's incredibly tricky to do this on camera, you know. In fact, just a minute, I'm just going to pause the video while I do this and then I'll be right back. Okay, and there we go. Ooh, can you see it? Is that in focus? That was a bit of a faff to do, but that's basically what we wanted. So we've got a little loop. It's essentially what they've got there, and what they've done is covered it in a little bit of that, it's like a green sealer, and I'll probably do the same there and just put a little bit of, probably some nail varnish or something, and just let it set, just to, so basically just so that that won't undo. So that's the first one done. Now we need another one of them. It's basically the same, it's just got a loop at both ends. Well, one end is tied onto the spring, and the other end's got a loop in it. So we can do that, we can tie that onto the spring on this side. Just loop that through. Tie that onto the spring. Do a double knot. Right, okay, sorry about that, but there we go. So that's tied on there with a double knot. So we've got our 300 piece there. That's our 300 piece. And then we need to measure off now 668 millimeters from there. So let's do, that's from there, that's 300 to there. That's 600 to there. Then we want 68. So that's 60. So from there we want 68 is to where my finger is there. So let's just make a little mark there, and we'll just double check that. Go on there, we'll just measure back, so we've got from there, that's 30 to there, that's 60, and then we should have about 8. Yeah, that's right, so we've got it. So wherever we put that green mark on this, where is it now? There we are. So we need to form another loop basically there. So we'll snip. In fact, I can now, because I know I've got enough excess, I can make this a little bit easier, so I can snip a bit further down, give us a little bit more dial card to actually work with. I might actually be able to show you me doing it this time. So we've formed the loop at the end there. We'll come a bit further down this time, so we've got a bit more room to play with. And what we do is we'll fold it over and back on itself. And then back through itself. Get hold of it and pull. There we go, and that's our little loop on the end. So that's the new dial card created. And now I've got the fun of fitting the thing. Now that bit that I've just done was the easy part. Fortunately, on here we do have a suggested procedure for dial card assembly. It says turn gang drive drum to fully anti-clockwise position. So if we go all the way that way, that I believe is, that doesn't feel very, make sure we're in the fully anti-clockwise position. Which we are. Okay. That's fully anti-clockwise. It's tape card temporarily to chassis with spring and position shown. So what it's asking us to do is basically to tape the spring into position, which is basically there like that. So let's do that. We can put that over that first pulley wheel just to hold it in place. There's a convenient piece of tape there stuck to my contact cleaner. That should just do nicely. I've never tried filming doing a dial string before, so I don't know how well this is going to work, because these usually involve me shouting and swearing for quite a bit of the time. So I don't like restringing radios. It's one of my least favourite thing to do. Right, okay, so that is loosely taped into position. Now tape card spring position as shown. It says lay card as follows in anti-clockwise direction. Tape card from tape over pulley A, which is that one there, down to pulley B. So let's start doing this. So we go from there to pulley A, down to pulley B, and along to pulley C, and then wind 2.5 turns on the tuning scale boss in a clockwise position. So we go along there, up there, no, get on there, up there, like that, and then it wants, it asks for 2.25 turns in a clockwise position. So we want to go right, so it's, sorry, I'm being an idiot. Come back up there, you stay there. This is why I hate restringing radios. I'm going to make you suffer through this. Right. That over there, then wind 2.25 turns on the tuning spindle boss, not the tuning drum, in a clockwise direction, taking card off bottom of boss nearest to tray. Right, so we go along there, we go 1 full turn, 2 full turns, then a half turn, Right, now, what do we do next? I hope everyone's enjoying this, by the way. Right. Continuing clockwise on drum, take card through top Henry and loop end into L tab. Right, so I think what they're asking us to do is to go through there, up there, around there, and loop that onto that bottom little tab down there, which is not going to be easy. Let's see what we can do. So we put that on that. Come on you get. Oh, so close then. There we go, that's on there. Make sure that's over there where it should be, it's not rubbing on the edge. Pull, oh, get in there. Oh, you little... So this is why I hate restringing radios. And if you try to restring one and you haven't actually got the stringing procedure, imagine trying to do this blindfolded. It's pretty much as hard. So at least we've got the manufacturer's stringing procedure for this radio. Sometimes you don't. Many radios, all you've got is the circuit diagram. Sometimes you don't even have that. So, I mean, basically for electrical repairs, often you don't need it, but for when it's something mechanical like this, having the right, so are we good there? Should we be back there? Right, I think that's right. Okay, let's carry on. Clockwise on drum, take card through top entry and loop into, attach other loop end R to tab Y, take out through top entry and Y, we've done 2 turns clockwise, blah 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 blah. Right, I think that's right. So I think what it's asking us to do now is to go down there, we go round there twice, so that's 2 turns, 1, 2 turns, and then we need to go through here, and as far as I'm aware, now that feels right, but I'm not sure. I think that I'm too short. I think you're going to have to bear with me for a second, folks, while I try and figure this out, so back in a sec. Okay, we're back, and it's absolutely amazing what not having the camera rolling can do, because Well, actually, I found there was an issue. Basically, this set has definitely been messed with in the past, because this actual wheel here, the tuning wheel, was actually out of alignment with the tuning gang fully meshed, like as it describes in here to start off with. If we look on there, can you see how the alignment of that? So you've got one screw pointing that way and one screw pointing down. When I had that mesh fully aligned there, that was in a completely different orientation. So basically I reset that and then just went through the stringing procedure again, and it went straight on, no problem at all. So if we tune now, we can see it's tuning nicely across the band. It stops there. So it is going full range of the tuning gang now, no problem at all. So I'm happy with that now. What we can do is we can put the dial plate back on and just make sure it runs smoothly with the dial plate on, and then we can do a little bit of reassembly. In fact, actually, once we've got the dial plate, oops, what was that just pinged off? So just bear with me a second, folks. Something has just pinged off the radio, and then probably never to be found again. Oh, it's the top for the automatic gain control. There, the little silver knob. Where the heck's that just shot off to? Sorry, just bear with me a second, folks. I've got to find that. Well, that appears to have pinged off into an alternative dimension, because I've spent about 40 minutes looking for it and I can't find it anywhere. So we'll carry on, because I want to see if I can get this video out. Hopefully it will turn up. If not, I've got a box of miscellaneous knobs and things off radios like this, so hopefully I'll have one. That's rather annoying though. Anyway, let's carry on and put this radio, put this dial plate back on, and then we can actually see whether the tuning rotates correctly. Oh, and that reminds me, there's something else I want to do, is a little repair before we go any further, which I noticed while I was handling the radio previously. Get in there. And that's the wire to the aerial is in a shocking state, and it can't be helping reception. So we're going to do something about that. Let's look here. Basically, you've got the aerial coming off the tuner there, and then we have another piece of wire which goes off to the long pull-up aerial, which comes off the back of the external aerial socket there, and this wire is literally just tied in place. It's not even soldered. So we need to do something about that. Let's remove it. There we go. See, it wasn't even soldered in place. Well, I mean, the wire's long enough actually for what we want to do. We just want a decent end on it, so let's cut that. We'll cut that crud off the end, and we'll tin that up and we'll solder it properly into place. I mean, some of the interference I was getting when we was first playing with the radio might actually be down to something like that. That's filthy. Let me just give my solder iron a quick clean. That's better. Okie dokie. Tin that up. In fact, on the other end, what we want is a little eyelet or something, because there's a little screw it has to go into, so we can actually farm that. We'll take, say, my screwdriver there, that should be good enough. And we'll wrap that round like that. So we form a little eyelet like that, and we'll solder that, and that will do to connect it to the little stud that we've got. I mean, we could actually solder an eyelet on, but it's not going to have any current going through it or anything. This should be fine. Come on. There we go. Just tin, basically just tin it up. There we are. So we've got an eyelet formed on that end there. That's to go onto the pull-out aerial. And we've tinned that end up so we can actually solder it properly into place here, rather than it just be twisted into place like it was. We'll solder that into place. There we go. That should be better. Right, and we've just really tin that up as well. I'm not sure how I'm going to connect. I'm probably going to end up soldering it like it was originally, actually, because I don't think I've got any of them tiny little spade connectors hanging about anywhere. So we'll just tin that up, ready for soldering back onto the speaker. Because ideally I'd put one of them little connectors on, but I haven't got any that size. So it'll have to be a soldered connection. Right, let us see whether the tuning dial is actually going to work as it should. Right, there we go. Yeah, that's working well enough. Excellent. We'll just have a check of the tuning condenser. Yep, that is fully meshed there. It's just off the edge of the scale. We'll pull it that way. So that was fully unmeshed. We get to the end and it's just off the scale and it's fully meshed. Excellent. Right, so that's looking good. The question is now, and are the actual markings going to be in place for us? Someone actually fiddled with the alignment on this set, which I do have my suspicions someone may have played about with, especially considering that the like I said, the drum for the tuning was all out of whack and everything else. What we'll do is we'll connect it up to the speaker. I've actually put the speaker back in the cabinet, and I did repair, like I said, the back there. That's now glued strongly back in place. Okay, we'll lash this up roughly on the bench. And where's that wire I've just soldered back on? There it is. So we can connect the aerial up. That doesn't look original either, the way that's I think that's a homemade repair as well. We'll have to look at that, see if we can do something a bit better, perhaps connect the aerial properly to the bottom of there. But for now, we'll see if we can get this to connect somewhere. Ah, yeah, we can shove it down there. That'll give us a good connection to the aerial. Right. Pull the aerial up. Oops. Smash my multimeter. We can connect up to the speaker. That's that one. We might just have to tack that one in place with a soldering iron. Oop. Now it's just tacked in place, so we can easily disconnect that after when we want to put it back in the actual case. But for now, like I say, I want to see whether the alignments anywhere near where it should be. Right, and we're going to have to connect it to some power. So we want the leads off the bench PSU, and turn that down as well because I was charging a battery with it. Right, we'll connect that up to the radio. So the radio's off. Black to black, red to red. There we go. Switch on the power supply. Switch on the radio. And we should have radio 2 obviously around between like 88 to 91. Somewhere around here we should have BBC radio 2. So let's see.
Century, from the poppies at the Tower of London to the new National COVID Memorial Wall. Join John Wilson at 7:15.
Let's see what station this is.
BBC News at 7 o'clock. The Foreign Secretary, Dominic Raab, has said Britain stands shoulder to shoulder with America in facing threats from Iran, Afghanistan and Russia. He was welcoming Anthony Blinken, who is on his first visit to London as the new
Well, is
US
that going to be
Secretary of
radio
State.
2? I'm not
The
sure.
7 foreign ministers are due to meet in the capital tomorrow. Mr. Blinken
Well, let it
stressed
play
the
for a bit
ties
so we
of
can test
friendship
the
between
volume,
UK
bass and treble and everything.
We've been
It's something I'm not going to get a
reminded of that
copyright
again in
strike on.
recent as we prepare to draw down our forces from Afghanistan. We've stood shoulder to
Nice and
shoulder
loud now.
for nearly 20 years, sharing a mission. The United States has no closer ally,
Bass.
no closer partner than the United Kingdom, and I'm very glad for the chance to say that again here today.
Boris Johnson has rejected calls from MPs and peers that it would be unsafe to resume foreign holidays from England next month, saying tough curbs would still be in place. The All-Party Parliamentary Group on Coronavirus warned new variants could be imported into the country, especially when people mix in long queues at airports.
Yeah, sounding pretty good.
EU
that.
member states will discuss plans tomorrow to lift restrictions on holidaymakers who want to visit the bloc. The European Commission wants to welcome people who are fully vaccinated or arrive from countries with low infection rates. The latest coronavirus figures show that one person in the UK has died within 28 days of a positive test. More than 1,600 further confirmed cases were reported. Police in Germany say an international operation has dismantled one of the world's biggest online networks for sharing images and videos of child sexual abuse. 4 German men have been arrested, including one in Paraguay, from where he's expected to be extradited. The Premier League has introduced a new owners' charter to stop any future attempts by clubs to break away from its control. There was intense anger among supporters after 6 leading English clubs tried to join the European Super League. And 2 television prank shows have been taken off air in Iraq after being heavily criticized for subjecting guests to a fake kidnapping and shooting. In one episode, an actress fainted after a fake explosive belt was strapped to her. BBC News.
Next, forget the denouement of Line of Duty. Lee is confronted with the naked truth.
On BBC One.
I'm Alan Partridge.
Guess
Did you
it.
know that this time with Alan
I'm hoping that's Radio 4, but I can't tell. I was hoping to get a BBC, this is Radio 2, Radio 3, Radio 4. That's why we actually just listened through that lot.
Why not tune in? Also,
Let's see if it's just going to give us which station we're actually on. So according to this, it should be BBC Radio 2 if this is in alignment.
Friday night at 9:30 on BBC One and iPlayer.
Now, Lee is a bit nervous in the Archers.
Right, so this is, we're definitely out of alignment. Because we're showing Radio 2 here, like I said, 88 to 91. Radio 4 should be like 93 to 95 up here. And now we're into some of the more commercial stations.
Come on, hold my tune.
State TV claim.
Now this will be Classic FM. Now this should be at 101. This should be like the last station you can pick up on this radio. So someone has actually fiddled about with the alignment on the radio, possibly to bring in stations they wanted to listen to. Up on this part of the band. Now I'm quite happy to have Classic FM as the last station on this band. I'd like to see if I can realign it to how it should actually be. We'll take it off station, but we've definitely fixed the problem with the amplifier in it. I mean, it sounds quite sweet. The biggest problem we've got now is, like I said, is someone has fiddled with the alignment on it. I am going to have to do some research now to see if I can figure out how to sort the alignment out. I've got all the equipment you'd need to realign an AM radio. Unfortunately, what I don't have, I don't think, is all the equipment I need to properly, I'll say this properly, realign an FM set. However, there are various things you can do. There's various dodges you can do, doing things by ear. Hopefully to be able to just get the alignment. Like I said, it's basically working, it's just the alignment's well off. It's been shifted up the band. What I need to do is realign it so I can shift it back down the band. So we've got Radio 2 back down here, and like I said, Classic FM. Classic FM right the way up here, and we're not interested in the stations past that, but like I said, I'd rather have the radio how it was originally. But what I think we're going to have to do is have a three-parter on this thing, because like I said, I'm going to have to watch some YouTube videos, possibly speak to a couple of people I know who know a lot about this. You know who you are, you two guys, and see what I can do about actually shifting the back. Like I said, shifting it back down. I know it's possible. I know you can do it without an FM frequency generator. But I need to speak to some people that know it a bit better than me, so I know what I'm actually doing before we attempt that. But like I said, for now, we have fixed the main problem with the radio, which was the
Yes, before the clap.
see if we can get a Classic FM, because I'm not going to get a there we go. As you can hear, the radio is good. The sound quality is excellent. Even the repaired speaker, there's no problem with that at all. Well, just in case we get a copyright strike, I'll shut that off. So yeah, we'll call this part 2 of the radio restoration. In part 3 we'll see what we can do about that alignment, actually getting the stations back to where they should actually be. And we'll do some final bits of cosmetics to the case and what have you, and actually get it ready to use. Like I said, this is going to be going down onto my boat. I thought actually, because I'm going to be using it inside the boat, I don't even need to worry about a battery, because my boat's wired with 12 volt sockets all throughout. Because all the appliances basically I use on it, the TV and everything, are 12 volts. I did have an inverter on there to give me mains, but to be honest, it was more trouble than it was worth. I just ditched it and went with a sole 12 volt system. So I can literally just have a lead that plugs into the power input on the back of here to my socket, which I can plug in, and I'll just use it exactly like that, like I said, for music inside the boat. Anyway, I'm going to leave it there for now. I hope you enjoyed this part 2. Like I said, I weren't expecting to be doing a part 3 on it, but with us having to do some alignment work on it, and I'll have to go and, like I said, I'll have to do a little bit of reading up and speak to a few people. We will do a part 3 on this and see if we can sort that out. So, hope you enjoyed this little update on the project. Thanks for watching, and goodbye.